our virtual Leap Technologies. I'm Joe Wazlowski,
I'm Dave Silverberg.
I'm Kyle Rector.
and we are all CGT students focusing in virtual product integration. Our sponsor for our project was Dr. Nathan Hartman. He's Associate Professor of Computer Graphics Technology. He's the Director of Purdue University's PLM Center of Excellence. He conducts a lot of research with Purdue and has published several research articles. Dr. Hartman graciously granted us access to the PLM lab, which is located on the 3rd floor in Noy, room 373. Here we were able to formulate our code that we needed, test our subjects, present our go, no-go presentation, and also we talked to a lot of grad students that were also in the lab, and they gave us a lot of good advice. The emerging technology we use is the Leap Motion Controller. It's very similar to the Xbox Kinect, except it's much more precise and focuses on a smaller area. It has two infrared cameras, or two cameras and 3 infrared sensors. And with this, it's really accurate, can detect individual fingers, hands, etc. It's being hailed by a lot of review sites and review companies as being very important. The MIT Technology Review Board said it's the most important technology since the smartphone. The code we chose to use was C++. We chose that because it's readily available at Purdue, and we actually have some previous experience using it. The final product was 326 lines of code. We chose to utilize 2 APIs, the API that came with the Leap Motion Controller and the Windows API. The initial 3D software that we used to test our subjects with was NX 7.5. Some definitions that we think you should know are human-computer interaction and application-program interface. The human-computer interaction is essentially a science of studying how people interact with computers and devices, and then figuring out ways to improve how people interact with those devices or computers. An application program interface, in regards to our project, is a pre-written code that sends data from our Leap controller into the software. Some other definitions are natural user interface and gesture-based interaction. A natural user interface is basically, in regards to our Leap, creates a interface for the user to use in a space or surface. So in our case, it's the space above it. Gesture-based interactions are interactions where a device recognizes a motion either by your hand, arm, or your face, or any other part of your body, and then through recognition of your gesture, it sends a response to the software. And now I'm going to hand it off to Dave for discussion of our problem statement.
Thank you, Jeff. So here's our problem statement that we came up with, and that was the current mouse-based interaction with 3D modeling programs does not provide a quick-to-learn way to manipulate the system in 3D space using gesture interaction. And so basically what we saw is that current industry uses 2D manipulations with a mouse and keyboard to manipulate a 3D object within virtual space on the computer rather than a 3D gesture device interpreting the space in front of your hands to manipulate the 3D space. So you're going from 2D to 3D rather than 3D to 3D, we think is more logical. Here's a look at our elevator statement. Virtual Leap Technologies is looking to improve user interaction with 3D modeling software in the industry. And we think that going from a 3D space in front of you to a 3D environment on the computer will be faster and easier to learn. Our team will be analyzing the effectiveness of a gesture interaction device as a means of controlling the program versus the traditional mouse and keyboard combination. And that's a little bit about what I've been talking about as far as using this 3D gesture device. Virtual Leap Technologies will integrate the Leap Motion Controller in the 3D modeling software by creating an application, and Kyle will touch on that a little bit later in the presentation. Continuing on, by conducting research, the team will determine if the controller offers current software's user interface. And the product is not only applicable to users of the software, but also could be useful to the software manufacturing companies for further development, as well as other areas in the industry that we think that this could be applied. So our research statement was, how will the use of gesture-based interaction technology used with a 3D modeling program affect the user's performance with that software? And the main variable that we were testing was time. And so the hypothesis that we generated was that a gesture-based user interface will improve the interaction of users of 3D modeling programs. And if that proved to be wrong, then a gesture-based user interface will have no effect on the interaction of users of 3D modeling programs. So during our research, the methodology that we used, testing was conducted on 2 different days. Each participant came for both days, and the reason we gave a 2-day gap between the testing was to maintain the accuracy of our results. We didn't want like memorization of the first test coming into play on the second test and that having an effect on the time that it took to complete it. So each day we had a distinct interface. One day the users would use a leap, and another day they would use the keyboard and mouse. A similar set of tasks was performed with both interfaces. Another way that we kept the results as accurate as we could was by actually changing the order of the tasks that were performed, but they performed the same amount of tasks, so it should take a similar amount of time if it was if both experiments were the same. And then we video recorded and timed each participant to completion, and that was so that we could go back and review each participant's time to complete and make sure that their start and end times were accurate as possible. So here's what our testing setups look like. The Leap Motion device on the left is all that was in front of the user when they were using hand gestures to control the 3D product. And the keyboard and mouse setup on the right is what is standard in industry today. So with that, I'll hand the floor to Kyle to go a little bit more into the product and development.
All right, so taking a look at the product we actually used for testing, our initial version, we had several different gestures based on number of fingers that allowed you to change manipulation modes. For instance, your whole hand, all 5 fingers, allowed you to pan the part around in 3D space. If you're unfamiliar with the term, it basically just means moving it around without rotating. 2 fingers allowed the subject to rotate the part. The only 2-handed gesture was for scaling, or also known as zooming in or zooming out. And we got that from a pinch to zoom on a touch screen, where you move your fingers apart to make an object larger. Similarly, in our program, you move your hands apart to make the object you're seeing larger, and together to make it smaller. Also, the 1 finger allows you to move the cursor, but in this version it didn't allow you to interact with the program in any way, just to move the cursor around. So we'll take a look at the product in action. They're using 5 fingers to pan the part, 2 to rotate, 1 finger just to move the cursor, and then 2 hands to scale it down and then back up. And then just a few combinations of those. As you can see, the tracking isn't quite accurate in that version. So, on to what we got from our study. We chose a within-subject structure for our study so that each subject's time was compared only against themselves. And from that, we were able to get a time difference to see which trial was faster for them. Also, we performed a t-test on our data to determine just how small of a difference could be considered significant. And what we found is a difference of 6 seconds or more could be considered significant. But based on our timing data, we could not reject our null hypothesis, which again was that a gesture interface would have no effect on the interaction with the 3D modeling program. We also issued a survey on the first day of testing, a pre-screening survey. Our survey gathered information such as class level, years of experience using any 3D modeling program, what 3D modeling programs the subject may have used previously, and years of experience just using mouse and keyboard in general. We also, when we were looking at our data, we broke it down based on years and compared years of experience, 1 year of experience with 3D modeling to 2 to 3 or 4. But the most interesting results emerged when we compared lumps of groups. For instance, 3 or more years of experience with 3D modeling programs versus 2 or fewer. So again, we had 30 subjects that attended both treatments. Only one of those subjects was unfamiliar with the concepts of pan, zoom, and rotate, so that shouldn't affect our results very much. But here's a breakdown of our subject pool as far as the 3D modeling experience goes. Over half had 3 or more years of experience with any 3D modeling program, but it's only 57%, so it's not much over half. And as I mentioned earlier, we took a look at the difference between 3+ years experience and 2 or fewer. And what we actually found is that those with 2 years or fewer experience with any 3D modeling program performed more quickly using the LEAP than those who had 3 or more years of experience. Similarly, we found out that those with fewer years of general keyboard and mouse experience also perform more quickly with the LEAP. And what this suggests to us is that even though you're using a 2D input in a 3D environment, you become accustomed to it, you become conditioned to use those tools. But if you maybe hadn't had much experience, our device might become more easy to use. A little further breakdown, over half of our users were familiar with CATIA and CATIA and Maya, which led us to the development of alternate versions of our product that work in those, which we'll discuss a little bit later. But only a third had ever used NX before, and of that third, all of them fell within the 4 or more years of experience with 3D modeling programs. So we encountered quite a few problems with our testing. What we came to call a jittery response, meaning that the subject would be transitioning between manipulation modes, for instance, going from panning with 5 fingers down to 2 for rotation, and the part would move in a way that the subject had not intended. It would jump across the screen or rotate instead of panning. We addressed that in the final version of our product, but it's something we experienced on testing day. Also, we had problems with the computer itself and NX. Occasionally, when the subject would be rotating the part, it would disappear entirely. That's something that the 3 of us had never experienced before in NX, and we've been using it for several years among us. And we only experienced it the first time on testing day. So, as I mentioned, we updated our version. We simplified it down to a few gestures. Obviously, scaling stays the same. It's the only 2-handed gesture and operates the same way as it did previously. We incorporated a mode cycling version, where if you move your thumb towards your index finger, it actually changes modes of manipulation. For instance, if you're using the cursor, you move your thumb towards your index finger, it's now in rotation mode. You do it again, it's in pan mode. The third time, it's back in cursor mode. Also, we incorporated a clicking feature, which I will show a video of in just a few seconds, so if you want to go ahead and change. So here's the new version in action. As you can see, using the cycling gesture to change to rotation, and then to panning. Also, the finger tracking is improved in this version. It's hard to see right here, but the screen tap is used as a click. Here's a better version of that. The screen tap is a gesture that the LEAP automatically recognizes, although it didn't come as a software update until halfway through the semester, so that's why we incorporated it late. But the screen, or the click, using the screen tap actually allows you to use all of the functions within the 3D modeling software. Here, just used for geometry creation. As we mentioned before, we also made alternate versions for CATIA and Maya because our subjects pool had quite a large base in that. A secondary goal of our project was to create a gesture scheme that worked across 3D modeling programs. So here is the mode cycling working again for rotation, panning, and cursor. And the reason we want to do this is because if you've ever worked with 3D modeling software, you know that the commands can be sometimes crazy to memorize. For instance, you might have to hold down a button and a mouse button or a key and a mouse button to rotate. And in a different program, it's just a mouse button. So we're hoping that this could make switching between softwares a little bit easier. Again, we made a version for Maya. We didn't want to just limit ourselves to the CAD space. But as you can see, it also used the same gestures for mode switching and then scaling. So this project in the future has a lot of possibilities. We've only got programs that work for NX, Maya, and CATIA of our most recent iteration. but there's no reason that more couldn't be added down the line for possibly SolidWorks or Creo, many others. And a possible research study on that could be just how well the new interface works across all the 3D modeling programs, how rotation translates between both, or all the different programs. Also, our new product could actually be tested. We chose not to implement the NX API directly in our program, but there's no reason it couldn't be done in the future, and that may allow for a more immersive experience. Let's take a real quick look at our website that we've had all semester. If you want to see our progress, you could see our press releases that we've had every week since Go No Go halfway through the semester. Our elevator statement, research question, a little bit about us, and if you need to contact us, this is a really good way at the bottom. So with that, I'd like to open it up for any questions.
On your pie chart, where's your data?
That?
Well, yeah, but can I see the timing breakdowns from doing it with or without the leap so I can see how much of an improvement it gave?
Well, actually, we found out that the leap doesn't.
Okay.
That's why we didn't reject our null hypothesis.
Okay.
It doesn't necessarily
So
improve.
the data was equal across the board essentially, correct?
Yeah.
And the contributing variable was familiarity? Is that what you thought it was?
From our, yes, what we thought was from our observation. Yes.
Why did you choose the gestures you chose, the 5 fingers, the 2 fingers, the...
Initially, honestly, the 5 fingers was because when you use panning in NX, the icon is a hand. And it sort of felt natural to us as we were developing it if you were moving a part around just kind of by dragging it that way. 2 fingers was used because it couldn't be one. And I mean, our initial product was very simple.
Do you think that if you had chosen other gestures, that you would have fixed that shape problem that you mentioned?
I definitely think so. That was one of the reasons we changed to mode cycling, but I'm sure there are other ways of doing it. Like I said, now Leap has gestures it recognizes, but those didn't come about in the developer's kit until we were really far into development.
It's all about timing, isn't it?
Mhm.
And the mode cycling's pretty like natural, like because all the icons, or at least in NX, the mouse, your cursor changes. It's like symbols, so you can keep up with the trip of the cycling on that.
What about comparisons against 6-axis space org controllers? You know, 2D isn't the only way to do this right now.
Right. We had talked about it after our Go No Go, maybe doing a 3-step comparison between mouse and keyboard, and then a 3D mouse, and then the Leap. And we just kind of thought it wasn't within the scope of our project. It understandably relates to it, but I think based on working within the semester, it would have been kind of
Could
difficult.
be a possible legacy.
Right, yeah, of course.
thing as well.
I think you discovered your research as you were doing your research. Your research is on which gestures.
Yeah.
Because that's what you evolved, right?
Mm-hmm.
You developed a strategy in the beginning to say, these features do this. And then as you tested, you got feedback which altered, and then you did a little more investigation. So your investigation is kind of evolutionary. And so, are you really at the point to test the the 2 types of interface yet? I don't think so. I don't think they're there yet.
No, I don't. So I think in your legacy documents, you need to include, this needs to be tested for accuracy as well as speed, because I'm not sure, as someone who uses a 3D package every day, I'm not sure I could actually create a game model and then do a UV breakdown and texture it with a leap. Give me a mouse and a keyboard, and that's a 4-hour operation for me for even a complex object. Accuracy is going to be a big limiting factor with these interfaces, I believe.
It is, and you've probably been using 3D modeling for a while.
Let's not put it in decades.
But that's kind of what we found, is that those, I mean, it's not, we found that pure user experience maybe not beat their time with a mouse and keyboard, but it was improved versus those who had been using 3D modeling or mouse and keyboard for a very long time.
For navigational. The second I'd
Oh,
like to
actually,
know what it's
yeah.
like when I need to move a vertex by 1/10 of a meter, sort of thing, right? Because I think these interfaces are going to have a hard time crossing that level of perfection that the mouse still gives us.
Definitely.
I noticed your hand is like out really straight, you're having to hold on there.
Mm.
Like, if you're having to work for a long period of time, like on a model, does it still work with your elbows on a table? Like, what do you do for fatigue?
Yeah, as long as it can recognize your fingers above the device, you could have your arm down.
Okay, just making sure, because
Yeah,
I'm
sorry.
probably what it is.
I guess kind of along those same lines, how wide can you get with your hand motion? I mean, does it have to be directly over the object, or can you be out kind of wide?
Our unit was a developer unit, and it's not as good as the ones that are actually going to be available in May. But what we found, they claim 8 cubic feet, so it's
2 by 2
supposed to
by
be
2.
about 2 by 2. But I feel like on our device there were some limitations. It could be improved.
Yeah, it seemed like the space was a little bit less on one side, I think it was the right side during testing. Then there's more greater space to the left of the device for some reason.
Yes.
How is this compatible for someone who has a disability?
We'd actually talked about this. It's kind of a limitation of the device as well because it requires, unfortunately, a lot of fine motor control. You could rest your arm on the desk, yes, but it does involve a lot of, like I said, fine motor control. So it's kind of difficult. I'm sure a version could be adapted.
Why time?
Why time? We chose time because we thought that was going to be one of the metrics we could most easily measure based on our tasks. And you're probably wondering why tasks? Because we wanted to test all the different areas that we made functionality for.
What else could you choose besides time?
Well, as mentioned, we could have done accuracy, but I'm not sure exactly how we could have measured that without, I'm not sure how we could have measured that in the program.
What else besides accuracy? I wish I was on Skype now, don't I?
Yeah, I do. But thank you for coming. I'm not sure.
Now, I think those are some of the things you need to think about. I think time is convenient. Time's always convenient. I think to really get at the nuts and bolts of whether or not this thing can be used effectively, to piggyback on Jeff's comments, I think you've got to work past time. And whether it's accuracy, whether it's degrees of accuracy, whether it's the nature of the space, whatever it is, I think all of those turn out to be potential legacy activities.
And precision and accuracy are different.
Mhm.
It gets to that point about, how precise can we get with this, and do we zoom in, and does that make things more precise, or those are all future testing realms that are pretty exciting, actually.
Another thing I was gonna ask you guys is, you started off with a mechanical CAD tool,
Mhm.
which has different kinds of commands in it than, say, not a mechanical CAD tool. Do you think at some level 3D modeling packages are similar enough that you can begin to generalize some of these things across? So sort of where I'm going is, you guys mentioned towards the end of your presentation that this could possibly be a way to help people bounce between package A, B, C, and so on. Are those packages similar enough, do you think, to allow this kind of bounce?
I think certain features. And that was part of what we mentioned as legacy, is that it could be tested just how well it translates. For instance, in CATIA and NX, the rotation doesn't work exactly the same. In fact, I don't know how NX does anything. But I think to a certain degree that definitely, at least the manipulation, the really simple manipulations can be translated.
So one of the other things I had written down was, would the CAD API help you? Being able to get into the event controller and actually affect the order in which it executes commands. Do you think that would help you?
I don't think it would help us in our goal to have a common interface, but in general, I think it could have to further develop just in NX or in CATIA individually. I feel like I said, it could be more immersive. because at the outset, we intended to kind of have the part as you would hold it, but that became difficult to work with.
You said the click was a gesture that came with an updated developer's kit. Do you think about trying to develop something different for clicking? Because like if you try to do a click and drag, does it have that functionality, or is it as soon as you move your hand back, the click goes away?
Right now, yes, the click goes away. In an intermediate stage, during our Pechacucha 2 weeks ago, we actually had this as the click, which became our cycling gesture. But in that instance, you could actually click and drag. In the future, it could be changed. What
What do you attribute the fact that you were not able to reject your null hypothesis? Why do you think there was not a significant difference?
I think it had a lot to do with the problems experienced in testing. Because if you weren't just right with our interface, it was difficult. That's why we made so many updates after testing.
What were some other potential reasons why there was not enough difference?
As we mentioned earlier, maybe being conditioned to mouse and keyboard, and any sort of new interface is kind of confusing.
So how would you establish a secondary experiment? Say you're actually promoting next semester's 411. What would you recommend to, now that you're wise and experienced and scarred by battle, what would you recommend for the next group that you really think would knock the socks off this?
I definitely think measuring gesture effectivity, like which gestures work, just comparing it to the gesture interface itself, finding out what does work best, and then, as Professor Burton mentioned, on in the future, then go back to comparing it to the keyboard and mouse,
Okay.
once this is more developed.
All right, so basically what you're saying is that the first step has to be find out what works best, and then do this kind of comparative testing. Okay.
And we didn't realize that at the outset of the semester. But
You were also limited by the technology you had, so. Okay.
Did anything not work in the software that you received? I mean, things that.
Like in
work a
the
certain
developer
way?
kit,
Yeah, the developer's kit that didn't.
nothing just didn't work. It may have taken time to figure out, but when we did, we got it to work in the way that we wanted.
So the commenting or the documentation?
Yes, it was very.
That was the problem. Early release.
Mm.
Yeah, okay.
And I don't know if I mentioned, but the Leap software has actually been updated 6 or 7 times over the course of the semester. And it hasn't been significant updates to affect how our program runs, but additions and streamlining.
That's one of the effects of early adoption. Is there an audio interface? Is this just your?
Not with the Leap.
When do you get to the point where
Other
you say-
devices like the Kinect, but that focuses on larger area and it's more
Sure.
expensive.
Yeah, because we're talking about, leveraging, our sensory abilities to interact with this thing. And so they're just curious. But it's a great output by standards, you guys. Anytime you get in this kind of development loop, what came to my mind was the evolution of typing. Some people hunt and peck, some people, use a QWERTY type activity. This might be beginning the development of those standards, whatever they might be, so I think it's a great opportunity. Yet to be realized, of course. How many degrees of freedom do you have for error in your handling? I mean, is this click, is this a click?
Or it's the mode change.
Yeah, but I mean, is this, can I just kind of
It's-
wish it to move and it would react? Or?
It's actually less sensitive than between, for some reason it measures rotation, all kinds of things that I would think would be more difficult to measure
Sure.
really accurately. Like it recognizes the minutia of a degree change,
Right.
but when it's changing number of fingers, it thinks this is one finger,
Okay.
which is something that we experienced.
Uh,
So that's why we adopted a different
But
gesture.
did it discriminate when you did have one finger? Were you able to set that degree of freedom so that it would recognize some spatial difference
No, it's all based on how much space it can detect
I
between.
had this vision of the president wanting to launch a bomb, you know, and he sneezes and, you know,
The end of it.
shakes his hand and it's all gone. Okay. Now, on the test subjects, how did you assign them to each area? Whether they did the gestural first or the mouse first?
We did keyboard on one day and leap on another.
But how did you decide?
Which day to
Did
do?
all subjects do keyboard the first
Yes.
day and all subjects? Oh, okay. So how did you parcel that out in your data? Did you take that into consideration that you'd already set up a bias or prejudice on the program?
No, we're not statisticians.
No, but
And,
I'm
we're
just
not
saying-
experimenters.
Yeah, well, but I mean, one of the reasons, one of the things we wanted you to do here was to wrestle with how to create this, or to control test effect on, you know, on your subjects.
I think our idea of control was having the day of separation in between. Although-
So you're trying to eliminate short-term memory carryover, is that
Right.
what-
Yeah, our statistician
Or
guide
long, yeah,
recommended
short.
doing 2 separate treatments on different days.
They didn't feel there was any contamination using one first or the other?
Mm,
Okay.
Which I thought was wrong.
When you did that thing for Maya, was that harder than adapting for NX or CATIA?
Once I had the framework, it wasn't that much of a difference.
So adapting to any familiar 3D modeling environment would probably be the same,
Right, that was,
fair statement.
yeah.
Were you linking against the Maya API or just blasting Windows commands into the app?
Essentially,
Which one?
the second.
Okay.
That's what I was curious.
Well,
So
so
if you're-
325 lines of code, I've seen header files bigger than that, so that was pretty impressive.
Do you have any imaging of your software development process or the way you did what you did and to define what you did first, what you did second, so on and so forth?
Not within our presentation, but in our legacy documentation, yes.
An elevator statement requires an unlike statement. And so the unlike statement for your elevator statement is not unlike existing, well, it is unlike existing mouse keyboard instruction. But the real thing is unlike existing gestural type interfaces, right?
Right.
What other ones are there?
I have seen someone use the Kinect for PC to do something similar,
Right.
but as you might expect in this early phase, gestures are completely different. And in our research, we found other studies using maybe just a camera, but I think those were a lot less accurate than initial development.
Okay. Thank you. You mentioned it wasn't accurate in the first study, and this may have been addressed earlier, and I just didn't catch it. What contributed to that? Why wasn't it, you know, I know the jittery thing, but you were talking about accuracy. Why wasn't it as accurate?
It had a little bit to do with just people's fingers being too close, or maybe their hand was a little bit off, and then just really the problems that we were having with NX.
Okay,
I think that was where most of the problems lied.
so that's where you developed your attitude with NX.
Oh, it's been a long time coming.
Okay.
Just out of curiosity, does the Leap only ship with a C++ API?
No, if you apply to be a developer, they have documentation for JavaScript, C#, Python. That's all I can think of right now, but I'm sure there's at least one.
Covers most of what everyone's using, so.
Right.
And what are they saying about their success in the industry? What's Leap saying? You know, how many seats do they have, or where? Oh, they haven't released, this is pre-release.
Okay.
Yeah, wow, you guys are building this for production, so,
Yeah.
okay. I'm good, everybody else? Okay? Okay, thanks guys, we appreciate it.